They're less common, but we're just going to go over acceleration time graphs. So the one on the top is the acceleration time graph. And what you can see in this first section is that it's increasing the acceleration. Now, the gradient of the line on an acceleration graph represents what's known as the jerk, but I don't think that's something that comes up. What you do need to understand is that in section 2 here, we've got a horizontal line. And so a horizontal line in an acceleration graph means constant acceleration. So it doesn't mean it's not moving. That would be a distance time graph, and it doesn't mean that it's got no acceleration, because that would be a velocity time graph. It means that it's moving with constant acceleration. So in section 3, what we've got here is the acceleration decreasing. In section 4 here, this would be when the acceleration does equal 0. And then what we've got here in section 5 is it actually decelerating. The other important thing that you need to know about acceleration is that the area under the graph, under the line, is equal to the velocity. So it's the area under and connected to the x-axis. So that would include sections 1, 2 and 3. And as I've just outlined it here, it would include this section here on 5 as well. So just to help you out, I've tried to draw a velocity time graph that corresponds with that acceleration time graph. So what we can see with the velocity time graph is that in the first section, where it's increasing the acceleration, this means that the velocity is also increasing, but we can see on a velocity time graph it's the gradient that's the same as the acceleration. So the acceleration is increasing as it goes along. And then we've got this section that corresponds with section 2 above here. So we've got constant acceleration. So now we've got a straight line on the graph, so that it's a fixed acceleration, if you like, throughout that period. Then in section 3, it's gone back to being a curve. Then in section 4, we've got no acceleration. So what you can see here is that the velocity is remaining the same. So we've now got a horizontal line there. And then as it decelerates again, it's a curve again rather than a straight line.